What if the ocean could send us a signal, not with sound, but with light? For centuries, sailors told stories of impossible glowing seas, vast enough to be seen from space. They were often dismissed as myths, a trick of the mind on long, dark voyages. But they are very real, and scientists are just now beginning to decode these mysterious messages, revealing a hidden language spoken in flashes, glows, and shimmering waves. Our planet has two great ocean-aching light shows. One is intimate and electric, the other is vast and ethereal. The first is that brilliant blue sparkle in a crashing wave, a phenomenon many call sea sparkle. It's a fleeting, dazzling display that can turn a nighttime beach into a scene from a sci-fi movie. The other is far more mysterious and grand. For centuries, mariners have described sailing into immense patches of the ocean that glow with a steady, milky light, stretching from horizon to horizon. They call them milky seas, saying the water looked like a field of snow. For a long time, these were just stories, logged in dusty ship journals and treated as legend. But with modern satellites, we've now confirmed they are real, sometimes covering areas larger than entire countries and lasting for weeks. So what's happening here? The truth is biological, a phenomenon known as bioluminescence, and it represents one of the most widespread and least understood forms of communication on Earth. To understand these signals, we need to explore two very different worlds created by two very different kinds of life. Section 1: The electric sparkle dinoflagellates. Let's start with the more familiar sight, the glowing waves. If you've ever seen a footprint light up on wet sand at night, or a kayak paddle leave a shimmering trail, you've witnessed the work of trillions of single-celled organisms called dinoflagellates. These microscopic plankton are a type of algae that drift near the ocean surface. During the day, massive blooms of them can be so dense they create what's known as a red tide, but at night they reveal their secret power. Dinoflagellates don't glow constantly. Their light is a defense mechanism triggered by movement. When the water around them is disturbed by a wave, a boat, or a predator, a chemical reaction inside their cells produces a brilliant blue-green flash that lasts for only a fraction of a second. The chemistry involves a light-emitting molecule called luciferin and an enzyme called luciferase. When agitated, the enzyme triggers the oxidation of the luciferin, releasing energy as cold, living light. Scientists call the main reason for this flash the burglar alarm effect. Imagine a tiny shrimp swimming through the water, looking for a plankton snack. As it disturbs the dinoflagellates, they flash. This sudden burst of light can startle the shrimp, but more importantly, it lights up the shrimp, making it visible to larger predators lurking in the dark. Like a squid or a fish, the plankton essentially screams for help, turning its attacker into a brightly lit target. It's a sacrificial, yet brilliant, survival strategy. In this world, light isn't just for seeing, it's a weapon, a warning, and a cry for help. Section 2: The ethereal glow, the milky seas. While dinoflagellates create fleeting, explosive light, milky seas are something else entirely. They are not a flash, but a steady, uniform glow that can stretch for over 100,000 square kilometers. For a long time, this was bioluminescence's greatest puzzle. How could such a huge area glow continuously? The answer isn't plankton, but something far, far smaller: bacteria. Milky seas are caused by colossal blooms of luminous bacteria, like those in the family Vibrionaceae. Unlike dinoflagellates, these bacteria glow all the time, as long as their population is dense enough. This is controlled by a fascinating process called quorum sensing. A single bacterium won't waste energy glowing on its own, but when their population reaches a critical mass, sometimes tens of millions of individuals per milliliter of water, they release chemical signals that tell all the surrounding bacteria to switch on their lights at the same time. These blooms are often triggered by the decay of massive algae blooms, which release a rich soup of nutrients that the bacteria feast on, creating a thin, luminous film on the ocean surface. Because it's a surface event, ships sailing through these milky seas report that their own wake is a dark black slash through the glowing water, the exact opposite of the bright wakes seen in dinoflagellate blooms. Scientists like Stephen Miller at Colorado State University have made it their mission to hunt for these events with new, highly sensitive satellite instruments, calling them his white whale of remote sensing. This research has confirmed that Milky Seas are most common in the nutrient-rich waters of the Northwest Indian Ocean, often linked to monsoon patterns. While we can now spot them from space, the exact reason for this massive coordinated glow is still a topic of intense debate. One intriguing theory is that the bacteria are trying to attract fish to eat them. That might sound suicidal, but for a bacterium, a fish's gut is a safe, nutrient-rich home and a perfect ride to spread across the vast ocean. Still, this is just one hypothesis, and the true purpose of the Milky Seas remains one of their greatest mysteries. Section 3. The Secret Language of the Deep. As fascinating as these surface events are, they're just the beginning. To find the true heartland of bioluminescence, you have to go deeper. Below 200 meters, you enter the twilight zone, and by 1000 meters, you're in the midnight zone, a world of perpetual darkness, crushing pressure, and cold. Sunlight is gone forever, and yet it is a world filled with light. A groundbreaking study by researchers at the Monterey Bay Aquarium Research Institute revealed a stunning fact. More than 75% of all animals living in the deep sea are bioluminescent. In a world without sun, life evolved to create its own. It's such a critical adaptation that it has evolved independently more than 90 times across the tree of life. Here, light isn't an occasional spectacle. It's the dominant language of existence, used for hunting, defense, camouflage, and finding a mate. The ways deep-sea creatures use light are as clever as life itself. For hunting, you have the famous anglerfish, which dangles a glowing lure in front of its mouth, a false beacon of hope that draws unsuspecting prey to their doom. Siphonophores, which are long, gelatinous colonial animals, use glowing lures that pulse and twitch to perfectly mimic the movements of small crustaceans, attracting fish. For defense, the strategies are even more spectacular. When attacked, the vampire squid releases a cloud of sticky, glowing mucus instead of ink, dazzling its predator while it vanishes into the darkness. The deep-sea octopus squid can even detach one of its glowing arms, which continues to flash and wriggle, creating the ultimate "look over there" distraction. Some jellyfish take the burglar alarm to a whole new level, creating a brilliant, swirling pinwheel of light when threatened, an unmistakable signal that's sure to attract a bigger predator to deal with its attacker. But perhaps the cleverest use of light is for camouflage, using a technique called counter-illumination. Many deep-sea predators hunt by looking up, searching for the faint silhouettes of prey against the dim light filtering down from above. To combat this, many squid and fish have lines of light-producing organs called photophores on their bellies. They can precisely control the brightness of these lights to match the glow from the surface, effectively erasing their own silhouette and becoming invisible. And finally, there's the language of love. In the vast darkness of the deep sea, finding a mate is a huge challenge. Bioluminescence acts as a personal signature. Lanternfish, for example, have unique patterns of lights on their bodies, letting them recognize members of their own species and even tell males from females. These aren't just random flashes, they're a complex visual vocabulary for courtship in the dark. From the electric blue crash of a wave on a dark beach to the ghostly, unending glow of a milky sea visible from space, to the silent, flickering conversations in the planet's deepest canyons, the ocean's mysterious signals are the language of life itself. It's a language written in the elegant chemistry of luciferin and luciferase, spoken in dialects of flashes, glows, and shimmering clouds. For centuries, we only saw the surface and dismissed these stories as fantasy. Now, with new eyes in space and robotic explorers in the deep, We're finally learning to read this language of light. We're discovering that these glowing signals are fundamental to the ocean's ecology, driving predator-prey dynamics, enabling communication, and revealing the profound ways life adapts to extreme environments. What was once a sailor's myth is now a frontier of scientific discovery. Each glowing organism, from the smallest bacterium to the most formidable squid, is a part of a beautiful, luminous puzzle that continues to inspire our curiosity. The ocean isn't dark and silent, it's alive, and it's speaking to us in a language made of light. If you are fascinated by the hidden mysteries of our planet, subscribe for more explorations into the unknown. What deep sea mystery do you find the most intriguing? Let us know in the comments below.